Hello everyone, in this video we are going to learn about bisection method. So it is a numerical method to find the root of a continuous function. So what do you mean by a continuous function? If a function looks something like this, curved, that is, it doesn't have any discrete values, then we can say that it is a continuous function. So this bisection method relies on the intermediate value theorem. Intermediate means medium. So if f of a and f of b have opposite signs, this is the theorem which states that if f of a and f of b have opposite signs, there exists at least one root of f of x equal to 0 in the interval a and b. So if I need to explain it more clearly, so if you see this diagram, suppose this is the f of a, f of x, suppose this curve. So if I say f of a, suppose a stands here, so this is f of a, so this is positive. And if I take another f of b, b point is here, so f of b will be here. So if I multiply f of a and f of b, that is positive into negative, you will get a negative number. So that is obviously less than 0. So that is what is given here. If they have opposite signs, there exists at least one root of f of x equal to 0 in the interval a and b. So between here and here, there will exist at least one root where they cross here, and here the value of x is equal to 0. This is the intermediate value theorem. So based on this, the bisection method is given. So let's go through the algorithm. So initially we will select the interval, that is the value of a and b. We need to select the value of a and b such that f of a into f of b is less than 0. Why we need to choose it in this way? Because if you see, if I take, we need to choose it so that f of a is suppose here. So what will be f of a? Suppose here we have f of a and here we have b. So this side we have f of b. So this will ensure that when we multiply f of a and to f of b, we are going to get a, we will be having less than 0, right? Because one is positive and one is negative. So when we get a number like this, it will ensure that our root will lie between a and b. So for this reason, we need to select a and b such that f of a into f of b is less than 0. That is, one is positive and one is negative. This ensures that the root lies between a and b. Next, we need to find out the midpoint. Calculate the midpoint. We will find it by writing c equal to a plus b by 2. Okay. Since it follows this intermediate value theorem, so we need to find out the midpoint. Then we need to find out the compute the function f of c. So whatever is the function, we will put this value of c there and we will find f of c. Now after finding f of c, there will be three possibilities. Now let's check the three possibilities. Now what are the different values of fc that can happen? So first is if fc equal to 0. So if you see this, if fc equal to 0 means obviously it will fall here. So it will, 0 means what? This point. So this is the root of the equation. Now if we see the second value, if f of a into f of c is less than 0. So as I have told, f of a into f of c is less than 0 means one is positive, one is negative. F of a and c is less than 0. If you see here, f of a is somewhere here and f of c is somewhere here. So the root lies between a and c. So we can exclude b. So what we can do, we can make this c as b. So what we will write? The root lies between in the interval a and c and set b equal to c. Similarly, if f of c into b is less than 0, f of c and b, f of c and b means f of c, so f of c is suppose here. I'm just assuming f of c is suppose here, this point, okay, and f of b is here. It means suppose this point we are having, f of c, and here we have f of b. So f of c into f of b, if it is less than 0, means root lies in this portion. So it means what? We can make this c as a, because it is obviously the root is not going to lie this side. It is going to lie between this point and this point. So we can make this a as c. So what we are going to write? We will write set A equal to C. So these are the three possibilities when we compute f of C. So gradually we will try to, so by updating these values, so depending on the values of fc, we will try to narrow down the interval between a and c or c or b based on the sign of fc. So these steps 2, 3 and 4, how many times we are going to repeat? We are going to repeat till this interval b minus a becomes very small, or the function value f of c or b minus a is less than a specified tolerance. We will give some tolerance value. So till this difference or this b minus a or modulo of fc becomes less than this particular, till it is greater than this particular tolerance, we will keep continuing. Once it becomes less than this one, we will stop. Okay, so let's see bisection method with the help of one example. So here we need to find the roots of f. This is the equation, or f of x equal to x cube minus 4x minus 9. Okay, so this is the equation, and in the interval we need to find, in the interval 2, 3, that is the value of a is 2 and value of b is 3 with a tolerance epsilon 0.01. So this is the equation. So first of all, we need to pick up values of a and b, which is already given as 2 and 3. So first of all, we will put a equal to 2 in f of x. So f of 2 is 2 to the power, we will put 2 in this particular equation. So it is 2 cube minus 4 into 2 minus 9, which we get minus 9. Okay. Now again we will put b value, which is 3, in this equation. So f of 3 is equal to 3 cube minus 4 into 3 minus 9, and we get the value 6. Now f of a is minus 9 and f of b is 6. So if we multiply both, that is, if you see the equation, f of a into f of b, if it is less than 0, then only we will proceed, that is, roots are present between a and b. So obviously f of 2 into f of 3 is less than 0, because negative number into positive number is negative. So we were sure that there is at least one root between 2 and 3. So we will proceed to the next step. In the next step, if we see the algorithm, we need to compute the value of c, that is the midpoint. So c equal to 2 plus 3 divided by 2, we get 2.5, right? Now according to the algorithm, we need to find f of c. Okay, so f of c, f of 2.5. So we will put 2.5 in this equation. So it is 2.5 cube minus 4 into 2.5 minus 9. So we are getting the value minus 3.375. Now we will have to see, this is f of c. Now we will multiply f of c with whom to get the value less than 0. So whose value is positive? F of b. F of 3's value is positive. So we can say that if we multiply f of c into f of b, that is less than 0. So if f of c into f of b is less than 0, so the root lies between c and b. That is, the root will lie between, what is the value of c? 2.5 and b is 3. So the value lies between 2.5 and 3. You see, it is given here. And we will set what? A equal to c. So what is the new value of a now? The new value of a is equal to c, that is 2.5. So what is the new interval? A equal to 2.5 and b equal to 3. So here again, in the second iteration, as I have told, a is 2.5 and b is 3. Again we are going to calculate the value of c, that is the midpoint. Then we are going to find f of c. So we got 2.75 here, value of c. So f of 2.75, if we put in the equation, we are getting 20.7, we are getting 0.796. So this is the value, right? Now this we will, now we will have to see this is a positive number, right? So f of a and f of b, how much it was? If we see the previous one, f of 2.5 was minus and f of 3 was positive. So in here we have got a positive number, so we need the negative one. So f of a we will take. So f of a into f of c is less than f of a into f of c. See, f of a into f of c is less than 0. So what is the new interval? A and c, and b we are going to put as c. So the interval is 2.5 and 2.75, and what is the new value of b? we are going to put the value of c in place of b. So this is the new interval. So like this we will be doing the iterations till the value of b minus a becomes less than equal to, what is the epsilon value we have taken? If we see in the here, the value of epsilon, the tolerance is 0.01. so till the value of b minus a becomes or equivalent to 0.01, we are going to keep proceeding the iterations. So here you see in the sixth iteration, the midpoint is 2.70, and which is equivalent to minus. So here if we put, so if we minus these two things, right, we are getting this number, which is equivalent to this is the 0.007 b minus a, so which is almost less than 0.01. so we stop here at this particular point. When you minus these two, we are getting this value, so which is equivalent to little bit less than 0.01. so we stop in the sixth iteration. So what is the root of this particular equation? So the root of this particular equation is, if you see, 2.703. so that is the f, that is the midpoint. We say the value of c, that is the root of the equation. So that's all for today's video. In this video, I have explained the algorithm of bisection method along with the help of one example, mathematical example. In the next video, I will show you how to write the C++ program for this. Thank you, everyone.